Okay, hello everyone. I hope you are enjoying the conference. Today we're going to talk about real-world challenges in code generation. Have you ever been on a roller coaster before? Cool. Was it scary or was it fun? Yes, both, yeah. Cool, that's what I expected. So roller coasters can be scary and they can be fun. And today we are taking you on a roller coaster ride. It will be built with IDLs. It will be full of Scala fun. It will be full of sharp turns of in-house libraries and deep dives into bug fixing and debugging. At the end of this talk, we want to discuss if you are ready for such a ride, if you're tall enough, or if your organization is tall enough for the ride, and we'll try to explain how we were successful with the ride that we're taking you. Speaking of we, my name is Michał Pawlik. I work for SiriusXM, and this is the important part. I work in an internal tooling team when one of my responsibilities is a testing framework. This will be relevant in a second. With me on stage is
Jakub Kozłowski. I also work at SiriusXM. I'm a lead software engineer there. And previously I worked on a related team, a tooling team, building internal tooling for API design and distribution. Now I'm working on the playback team. And speaking of playback, let's talk a bit about the company, just briefly. SiriusXM is a leading audio entertainment company in North America. One of the things we build is this app, which is based on our streaming platform for music, sports, news talk, and podcasts. And we are heavy users of Scala, mostly Scala 3 in production, if not only Scala 3 actually. And we're trying to grow our presence into open source. One of the things we do is this snapshots4s library, which helps you do snapshot testing. So if you're interested, have a look or come talk to us later. We're happy to talk. And if you're from Ireland, we are hiring. So also, let's have a chat. But we both do other things as well. We have blogs about Scala and related technology. I also have a YouTube channel with videos about Scala FP and everything else, really. And we also publish libraries under this umbrella of the Polyvariant organization. You may recognize Better 2String or STP002 or our Learn Scala initiative. If you're interested in this again, or in Smoothie4S, the blue thing, come find us later to grab a sticker and talk more about this. So let's answer the question, are you tall enough for code generation? And we're going to have a story, right? So the story starts with a one-line change, which it's a one-liner, right? It's not suspicious at all, very innocent looking. We're just removing a supertype from an object. But it's really not innocent at all. It ruined 600 tests, or it could have, at least. In this talk, we will show you how the story started and unfolded, how we used Scala quotes and the Scala macros API to save ourselves, and finally, how to tell if code generation is your thing, based on our experience with it. To answer how we landed in this mess, we need to take a few steps back and rewind to a few years ago. But for the record, remember, this is just a conference talk story, and the events presented do not necessarily reflect the full reality of what happened. So it all begins at a company we worked for a few years ago. Let's call it the company. And this background is not accidental. The company decided to build a new streaming platform, and because it was a new platform, it would be a fresh start, a green field, if you will, with lots of opportunities to start fresh, do things right as we always dream of doing, right? And because we are doing things the right way, we're proper engineers, the system is going to be composed of event-driven, highly granular microservices with a lot of cohesion and all that, all the buzzwords at the time. But with lots of events, which this event-driven platform would surely have, comes a lot of trouble. All the features that need to be implemented would require tens of APIs and probably hundreds of types of events. In order to provide a consistently great experience across all the distinct types of devices and platforms that our users expect to use, we'll need to support processing these events with multiple languages on the back end, multiple languages on the front end, on mobile, whatever language the mobile people use. And the front end people probably use like JavaScript, TypeScript. On the back end, we would have Scala, maybe something else. We'll see, right? But we need to be flexible and accommodate for all of that. Then we have the additional concerns, such as documentation of each of these events. We need to know, when using such an event, we need to know what fields it has, whether they're required or not, what the type is, of course, things like that. Maybe we need to persist these events so that we can analyze them, maybe do some recommendations based on that, or maybe we just do it for our kind of safety during incidents so that we can rerun these events, reprocess them again to rebuild some lost state. And on top of all this, we need to make sure all these events change in a compatible way. Same with APIs, so that something we build today is going to continue to work in 10 years or whatever, how long we expect it to run. Doing all this without some kind of automation or tooling seems like a lot of extra work and something that might easily just become untenable. And it's just a massive distraction from what matters, the business logic. So one of the ways we can make it less of a problem, all these things, is by using an IDL, an interface definition language. In this world, everyone would use the same language for defining the schema of the events, the APIs, all of that. And because it's one language, all the teams would understand each other when talking about it. You wouldn't need to know about the intricacies of the language that your peer is using. So to understand what the endpoints actually do. From the schema, we would generate some code to get both the clients and the servers, consumers, producers. We would generate documentation, and anything else that we need from these outputs that I mentioned before would also be based on the single source of truth, some statically analyzable schema. And schemas can be analyzed statically, and they can be manipulated like data, which they are. So we can do things like compatibility checks because we have one version of the schema as one value, a previous version of the schema as another value. We just check if they have changed in a strange, risky way. And then we can flag it to the developer. In case you're not sold yet, there's so much more. This is just the tip of the iceberg. We can generate client code, server code, even a command line interface, and then all this. So it could be worth it. And one of the IDLs that does all this and that we considered was Smithy. It looks like this. I'm not going to get into the details, but notably we have this operation and the data types that it accepts in the input and that it spits out in the output. All of this is in the spec, and we can reason about this like data. Smithy is language and protocol agnostic, so it can be used with multiple languages, not just Scala, not just TypeScript, anything you like can integrate with it. And it's also protocol agnostic, so it's not just HTTP. If you saw these HTTP annotations here, this is not part of the language, it's part of the standard library. And you can replace it if you want. You can use extensions to it, you can wrap it in your own things, build support for other protocols, whatever you want. It's a small language, so learning it is fairly quick, and there aren't a lot of complex pieces in it. But it's extensible, so it can grow basically without a limit to support any organization's needs, kind of like Scala. On this extensibility part, it's definitely not on the small part. Smithy is not some random project from someone's basement. It's made by AWS, people who know very well how to maintain hundreds, if not thousands of APIs. So it's a mature baseline, battle-tested for years, and it's very easy to integrate with because it has a semantic model, so you can kind of query information about the shapes in this graph of shapes programmatically with quite a lot of ease. Last but not least, thanks to the good baseline, it already has good Scala tooling, and Scala is our favorite language at the company, so we like that. We even had an in-house maintainer of Smithy for S in the company, which will become relevant later in the talk. So it seems to check all the boxes, and that's why the company went with Smithy and Smithy for S. Smithy for S is the Smithy for Scala. It's a project that supports, that provides you with code generation from Smithy to Scala, as well as runtime support so that the generated code can actually do something. And again, I will not get into the details here, but on top of just generating case classes, which you might get from other code generator tools, some of them, you also get the generated code actually captures all the metadata from the input. For example, the default value of this name field is captured as both a default parameter of a case class, but also it's part of this schema val in the companion object, which is available as an implicit, and we can kind of automatically find it at runtime. So yeah, let's recap. In the company, we use Smithy, the IDL, to describe our specifications, APIs, and events. And then we have Smithy for S, which gives us code generation and runtime support for Scala. In particular, it provides us with clients and servers for our APIs. On top of that, we have the company tooling, so any kind of customizations for the company standards, any validations, enhancements also live here, and we extend the standard Smithy facilities with additional stuff on top of the standard library. And finally, we have this API monorepo. It doesn't have to be a monorepo, but this is the choice. Just one place where everyone can collaborate and contribute to the same source of truth where all the specifications of all the APIs and events live. And from there, we distribute artifacts which can be consumed by applications to generate that code and actually embed it into their runtime. And the last thing that we need to do is just the developers of these applications need to implement the business logic. But something is still missing. As our system grows, we need to maintain its quality over time, and we need to make it consistent. And the perfect tool to ensure continuous quality are end-to-end tests. And we have all these building blocks. They are actually a very solid baseline for not only building apps, but also writing these end-to-end tests.
Yes, hence we have created this in-house E2E testing library, or framework as you call it. It is based on Weaver, and it integrates the existing APIs, the things that we have in this monorepo. It utilizes the clients that you have in Smithy for S, but there is still parts missing. Like you need to know where the apps are deployed, right? Or what is the configuration, or maybe how do you authenticate, all of the boring stuff. So we decided we could try to bundle that, the existing components and the configuration, and provide the users with the testing libraries so that E2E testing can be cumbersome and maintaining that can be like problematic sometimes. So we wanted to provide the ease to our users. And before I explain how the framework works, I want you to meet one of our users, which is, well, let's call him Damian, and he's our workmate. Damian wants to write an E2E test because he's a good engineer. He already has the data model in API, like monorepo, and he already has the API clients to like contact his services, right? So he should be pretty close to writing a proper E2E tests. So here is what he wants to test. In this diagram, you have the test on the left. Then in the middle, there is the service that he is responsible for. So he will invoke his greeting API. He will greet Scala user. And the API is supposed to send an event to the event bus. So we want to test that. We want the test to consume the event from the event bus and make sure that it was there, it had the proper user and all of that. So here is the code. And hopefully it's pretty easy to read. The business requirements are there. There is the Scala user, and there are two important bits to it. So first of all is the API call. So to make the API easy to discover, we have this testing namespace in which there is APIs, right? And notice that in the APIs, we already have this greeting service present. So the user doesn't bother about creating the client. He doesn't care about what is the underlying HTTP client, what are the authentication methods, all of that. He just expresses the business need, right? So he invokes the service. He, in particular, greets the user, and he is done. Then there is his assertion. So he expects the event to be sent, and the event is user greeted. He wants to make sure that user.name matches whatever he sent, right? So it's pretty nice. It's a very high level of abstraction. He doesn't need to care about the wiring, so it's neat, right? And for the purpose of exploring this, going very deep into the bug later, I need to focus on this expect event API for a bit. So how does the framework know what is the stream name? because under the hood, there's probably some sort of like SQS or maybe Kinesis or whatever that is. And we need to know how to find whatever the source of the data is. So yeah, let's enhance a little bit and see some of the details of the implementation. So you notice that we, on the slide, we provided the name of the event, right? We provided domain event.userGreeted. So this is something that is generated by SMIFI4S. We have the case class that models the event, and we also have some companion object with the details. Jakub explained that in just a moment ago. So the companion object, it extends the shape tag, whatever that is. It is just like related to the case class, right? It in the bracket, it relates to the case class. And then there is this ID. So one thing that you need to know about the ID, that it is unique. So there will be no two shapes that have the same ID, which is something that we could use to like map to some like real infrastructure, right? So yeah, we want to utilize that. And the method from the internals aren't that important. Let's focus on the signature. So in the signature, you can see that we accept the shape tag, really. So we are not saying that this needs to be a companion object. We just like rely on the fact that SMIFI4S did that for us, right? So the companion object will extend the shape tag, and this helps because the A here helps the type inference. So if I provide the name of the companion object, then in my predicate function, the compiler will know what types we're working with. So that's very useful. And then because we have the tag and it has the ID, we can translate the ID to some sort of like infrastructure that already has the events. So that's cool. So to recap, there is this underlying method that maps shape ID to whatever infrastructure, to the stream name. Then it is utilized by that method expect event. And this all works because SMIFI4S does this nice thing of extending the object with a shape tag. So that's cool. That's cool for me as a tooling developer. But what our colleagues really care about is that they could write this nice little code, express the domain needs, and yeah, they could move on. And we did move on, and a few moments later.
Hello, it's me, a SMIFI4S maintainer, a completely new person. You have definitely not seen me on this stage before. As all this was unfolding, I also had some stuff to work on. So I would look at the bugs that people open in the issues, and I saw this bug report from this Jay Kozlowski person, whoever that is, and I decided to work on this to fix the bug. And I did. I opened the pull request, and we had a brief discussion in the comments with a different maintainer. He suggested, long story short, don't read this, there is a potential issue with implicits, and depending on some widening of types, you may get one implicit or another, and it may actually change the behavior of your program. I agreed. Let's take a look at what's actually the problem. Here you have a schema, or a SMIFI schema of a SMIFI union, which targets one member. So we just have one case, but imagine it can grow. And by default, normally in SMIFI4S, we generate each of these things in a separate file, and they're not part of one single hierarchy because this struct might be used in different contexts as well. However, this ADT modifier is something specific to our library, which tweaks this behavior and basically inlines the definition of the structure into the companion object of the union. This may be just a bit more convenient if you're used to idiomatic Scala code and sealed trait hierarchies or enums. It looks like this, basically. Otherwise, we would just kind of wrap the existing struct. So if you treat the member of the union as an instance of the union, or in Scala, the sealed trait, everything will work fine and work as intended. Your encoding of your JSON encoding or any other encoding of the union will have that tag on the top, this S signifier, which comes from the spec here, from S sample struct. And under that tag, you'll find the value of your structure. However, if you do not widen to the union's type and somehow it gets treated as the structure alone, you will actually still encode a structure. So no tag, and whoever expects a tag to be there will not be able to read your data or your events. And this is clearly a problem. So we removed the shape tag from ADT union members. We do not really need it. We have other means of accessing the same data within the library. And now the illegal scenario no longer compiles, or at the very least you can make it behave as intended, which is probably even better. Looks good to me, right? Let's ship it.
And they did. And I'm watching my I'm watching my support channel, and guess what? Damon reaches out and he says, well, I've been updating the library dependencies because you do so, you're the good engineer. And suddenly he gets like this random compiler error, and since I knew about that PR that was created before, we knew what was to blame, right? So we have been relying on the shape tag, as I have been explaining. We've been expecting the shape tag in the API, and now it's missing, and what do we do now? Well, there are a bunch of ideas we could have. We could change the behavior of the E2E testing library, or maybe talk to our users to use it differently, or maybe we could revert that change. Maybe we can convince them. How do you go about that?
Yeah, well, why don't you change your API to adapt to this scenario? Because all you need to do is change one method, this expect event, so that instead of a shape tag, it requires a schema. That's just, for your users, it's just like a one-line change. Just add the schema to their tests.
Yeah, it's one-line change on a snippet for the conference, but we remember that we've been talking about 600 tests and plenty of users that are already unhappy that they need to change something. So this would require like a lot of work on user side, so that's not great. Even if we use like maybe Scala fix rule that could cover that, that's a lot of like coordination and working with people to accept the PRs, merge them. We would like to avoid that. Like, why do we need to do that in the first place? It was working, it's broken now. Why wouldn't you like revert that change maybe?
Well, we could, but we really don't wanna. We don't want to keep like food guns in the library because if you just use the wrong implicit, it's very easy to just get the completely wrong behavior and break even your own system. You'd suffer from that probably. And it's just against the principles of SMIFI4S, one of which, like the core principles, is that the generated code must help you get correct behavior. Just correctness is just one of our top goals. We cannot sacrifice that. And also, I don't really feel comfortable bending like open source principles because catering to the needs of one commercial adopter is certainly something like that and kind of like could be interpreted as a breach of trust or just ambiguous moral actions. And at this point, it's probably no longer possible for me to pretend that the SMIFI4S maintainer and this Jay Kozlowski person are different people, because we are the same person.
Who knew?
Who knew? And if you find yourself in this kind of position, if you find yourself using something at work that you do on your own time in open source, you may want to keep your roles independent and your concerns separate, but in the end, you're one person, and you try explaining these two roles to your employer, and you may just find yourself in this conflict of interest, because on one hand, you want to be in line with open source principles, you want to be a good member of the open source community and do things right. On the other hand, you also gotta eat, and you need to make your employer happy. And you may have to sacrifice something. But thankfully, I didn't have to, because we had a surprise option C.
Yeah, so Jakub's having this internal monologue, and I'm just trying to focus on the work. So I came up with this secret option C and with my coworkers. So yeah, we were looking for this least painful option. So we wanted to minimize the cost on the organization. We didn't want people to rewrite the 600 tests. We wanted to reduce this time spent on coordination. Preferably, they would just bump the dependency and be done with this. And if there is the complexity, and inevitably it is there somewhere, we want to hide it in the framework because like we can cope with that in our team. So yeah, let's see how the surprise option C unfolded. So just to recap, beforehand we had this domain model generated from SMIFI4S, and the important part that was there is this extends thingy. So object extends the shape tag, right? It was there. Now it's no longer there. But you will notice that it is not missing any of the crucial information. So it still has the ID, which is the important part to translate to the stream name. And it also still has the schema as Jakub or his alter ego suggested to use. So yeah, let's try to utilize that. Again, the recap of the method that we have been working with. This was the signature of our method. It depended on the presence of the shape tag. We can no longer depend on that, right? Shape tag is missing. So what do? We need the ID, right? So let's just put it there. Also, like create this extra type parameter for the companion object, and let's try to work with that. Now the compiler is not happy. Everyone is not happy, either the users or the maintainers or the compiler now. The compiler is not happy because he doesn't know how to connect the companion object with the case class, right? So what do we do about that? We need to help the type inference working somehow. How? Well, let's add another thing. So we had an ID and we had schema. There was not much to choose from. And the schema has this trait, this property that it relates to the event it describes, right? So in the schema, there is the event type. So if I provide the companion object, the compiler will already know what type it refers to. So that's cool. We have fixed the type inference. And this code will compile, right? But this is ugly, right? Like having all of those braces, those upper bound structural types. Let's do a little cleanup. So we could also use the type alias there. So let's call it a shape tag like, because it used to be the shape tag. Yeah, and let's be done with this. I mean, the API looks correctish. Yeah, so maybe that's enough. Where our users are creative, and they could create something that is not really expected. So they could create a different kind of like object that also satisfies this predicate in the signature. And what would happen when they invoke this expect event with that? Nobody knows, and nobody expects Spanish Inquisition. We also didn't expect Spanish Inquisition, so we wanted to protect ourselves from this kind of like API abuse. To do so, we thought maybe if we could have like implicit thingy that would guarantee that the event type and the companion are actually in this case class companion relationship, right? So if only we could like have that out of the box. And this is something, if you haven't seen that pattern before, this is something we call given evidence. So just to digress really shortly about the given evidence is something that you can see on the picture. So let's say you have like a proof type. It doesn't need to be like implemented or anything. You can have a method that expects this proof to be present somewhere. Like somebody needs to provide the proof that implicitly or in the given scope. If the proof is not present, the code will not compile. But if you generate it either by hand or maybe have some sort of like a mechanism that can create it for you, maybe a library or something, that would compile. So we thought, okay, let's say if the implicit or the given evidence is not found, we will guide the client that they are doing something wrong. They shouldn't be invoking the API in this particular way. And yeah, the only like left part was to actually have the evidence out of thin air because we don't want to create all of the instances like by hand. So we figured the compiler already knows all of the classes and all of the objects, and it knows if they are like in those relationships. So maybe we could ask it gently to generate all the instances. And there is a way to do that. You can do that with macros. So how do macros work? Well, it's not that magical. You have like in the regular flow, you have a programmer that writes the source code in the source file, then puts it on top of the compiler, and the compiler produces some like bytecode, right? But there is this like magical step, and I want to do like short attention check. Who has written a macro before ever? Who? Half of you? Who has written a macro last week? Did you enjoy it? Yeah, yeah, that was convincing. So macros are not your like everyday bread and butter. It's more of like a last resort. There are few people who are excited about writing macros every day. You shouldn't follow them that closely. No, sorry. I mean, yeah, but you shouldn't like write most of your application code as a macro. You can agree on that, right? But yeah, macros are macros are pretty useful in this sort of situation. So macro is the code that is executed not at the runtime of your application, but it is executed by the compiler. And we can ask the compiler, like write the code for the compiler to instruct it what kind of instances we're interested in. And yeah, let's see how you write this very simple macro in practice.
Yeah, I'll skip over most of the details because this is not a macro talk. I recommend rock.jvm content for this and the official documentation. But yeah, basically we want to have something that, given two type parameters, creates an instance of companion evidence for these two type parameters, or not, if they're not actually companions of each other. So we're going to have this inline given, so it's going to, whenever we need a companion's evidence, it will be basically provided, like copy-pasted by the compiler into that place, kind of hand-wavy explanation. So we're going to use this quotes instance. This is basically our entry point to any kind of metaprogramming. And our goal, again, is to tell whether this class has a companion, which is the same as obj, right? So we build some kind of representation of both of these two types, and then we look for the actual companion of class. And once we have that, after some working with this a little bit tedious API, if I can say that, and we check if this is actually the same thing. So if the actual companion of the class is the same as the companion we thought it was. And if that's true, we just return an instance that's going to be inlined into the call site of the macro. Otherwise, if this is not the case, we can fail with an error. We can even say what the actual companion was, although that's not happening here. And that's basically it.
Cool, easy, right? I hope you write macro this weekend to experience how easy it was. The bottom line is that this thing helped us a lot. So when the user tries to like invoke the API with this weird object that you have created, there is no longer Spanish Inquisition. Instead, there is a compiler error, so something much more predictable. And it instructs the user that they have provided the user greeted, and we have been expecting something that is a companion object. So they already know what they did wrong and how to like proceed towards fixing that. So problem is solved. Macros and like clever use of those type parameters saved the day. We've been able to save 600 tests. I mean, we had to do some like maybe type gymnastics, but that was hidden on the end of the team responsible for the libraries, not at the end users. The change maybe was not binary compatible, but then again, this is a testing framework, so users care that they don't need to rewrite their code. They don't depend on the tests, hopefully, in their like business code. And again, our friend Damian moves on. So let's move on as well.
Now it's time to answer the big question you've been waiting for. Are you tall enough for code generation? As you've seen, code generation can be incredibly useful, but it also has its own problems and requirements. And yeah, it may be or may not be a good fit for you. And it's actually not a yes or no question because there is a maybe option. So we cannot tell you if you are tall enough. Only you can tell if you are. But we can try to define what tall enough means so that you can make your own informed decision. First, can you convince your entire organization to commit to IDLs? Or maybe even not the entire organization, but at least like some big part of it. This is an important question because using these things, it just works best if you make this kind of decision early on, when there's something new to build and the chance to start fresh with a clean slate. It could be a new product, a new platform, but probably not just like a new feature, something bigger. It may just be tough to introduce something like this later when there's some legacy already built, and you may even be unable to completely migrate off to this new world because the IDL will put some constraints on you and you may not be able to fit all the existing APIs into this world. And even if you are, migrations are expensive, so it's always going to cost more. And you really, really want the entire org's support because the benefits of IDLs shine as more people are using them, and ideally, if everyone is using them, and the longer you do it, the more you actually see the results. But you actually will need to wait for them a little bit. In the beginning, it will be friction, it will be a bit of overhead, but in the longer term, hopefully you will see the gains and more of them over time. Can you accept some loss of flexibility? This is an important question because the IDLs have constraints. They require a certain structure, and they may be missing some features that you know from your own programming language. You will not see hierarchy-kinded types here. You will not even see type parameters in Smithy, because it aims to support multiple languages all across the board. C doesn't have type parameters, so Smithy also doesn't. But you know, with sanity, right? Like it has lists, for example. So it's a trade-off of simplicity of the language and being language agnostic, basically. As I mentioned before, you will not always be able to fit all the existing APIs into the world of your IDL. For example, in Smithy, there's this one very common question: can I have an endpoint that requires one header, HTTP header, or another one, but not both of them and not none of them? So just 2 options out of 4. And this is not possible to express with the standard HTTP traits in Smithy. It's a design decision. I'm not sure exactly why. I have some thoughts, but this is the choice, right? And you may be able to customize this with your own HTTP support or something different, but still, that's extra work, and you need to count that into the budget, basically, of how much complexity you want to add. And yeah, these customizations don't come for free. They need to be built and maintained. Which leads me to the next point. You need someone to actually do all this maintenance. And you probably want a dedicated tooling team for this. You need a team of experts with a very particular set of skills. They will be the ones defining the company standards, with everyone else building the validations that actually ensure these standards are followed, and any kind of extensions on top that are built, that's also probably going to be in this team. They will also be these kind of housekeepers. They will help teams find best practices. They can consult the teams with kind of API design decisions and review the shared libraries, own the shared libraries, and so on. They will also need to integrate the tooling into the software delivery lifecycle, including basically all stages of that, like deployment and maintenance. Maybe you want to run compatibility checks during deployment or report like versions at runtime. All this will also kind of fall into this kind of team. And the point is basically you don't want to scatter these responsibilities across multiple teams of like normal product people just because it's a distraction. And you will probably not build this expertise. And they'll be the ones who also educate others on how to use these tools, how to deal with problems. They will be writing documentation, not writing, just creating documentation in any form. And they'll provide FAQs and just provide support for daily problems and daily tasks. Most importantly, you need to ask yourself if you actually need any of this. And this is kind of a checklist, kind of not. Do you have the scale? There's some number, I'm not going to name it because I do not know, but there's a number of like teams or domains or services that you need to have for this to kind of pay off, because it no longer is possible to do this manually, or it's just too risky, too error prone. And yeah, I'll know it when I see it, but I cannot give you a concrete number. What can help answer the question of scale is whether you are able to keep up with the rate of change in your APIs. If you find it hard to stay in sync with the other teams and stay on top of all the changes that affect you, this may make it easier. Another reason why you might need this is for communication. If the process of discussions around APIs is something you'd like to improve and maybe centralize, again, this might be for you. And last but not least, if you need to support multiple tech stacks or programming languages, using an IDL is a great way to ensure that you never kind of leak a particular language's design patterns into the API, which would then make it harder to consume from other languages, or might make it harder to just abstract into the IDL world. But even if you just have one language, maybe this is something you want to be using. But there may be better options, like maybe in Scala you want to use Tapir for like smaller organizations. If this sounds convincing and you would like to have a look at Smithy in depth, I have given a talk on Scala a couple of years ago, and then there's all these resources, especially the awesome Smithy page. There's so much, and it's constantly growing. So yeah, and also we can have a chat about this later. So this has been our roller coaster, and at this point we hope you already know if you're tall enough or not. maybe you don't know, but at least we hope we've given you some food for thought. So a reminder about the stickers, just find us and talk to us. And yeah, this has been the talk, all we have. Thank you for coming and enjoy the rest of the conference.
Thank you.